Welcome to Pomodoro Joe for Friday, April 14th, 2023. Today we're doing LeetCode problem 516, longest palindromic subsequence. This is a medium problem. Given a string S, find the longest palindromic subsequence's length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. All right, so all that's saying is we have some input string S, and we are allowed to remove all or none of the characters. Let me try one more time. Given the input string S, we are allowed to use the entire string, or we can remove some of the characters, as long as we don't change the ordering of the characters. All right, so with that, we'll put 25 minutes on the Pomodoro timer and get started. So I think for this one, we'll take the easy route first, and then we'll iterate. So we'll start with a recursive solution. So the easy route with the recursive solution is just saying, is this string a palindrome itself? If it is, we can return the length of the string. If it's not, then we go through and we remove one character at a time. Let me rephrase this. We'll go through and remove each character, but only one at a time, and recurse. So we'll remove the first character, and then we'll call a recurse on the remaining string. Then we'll go back to the original string and remove just the second character. And then we'll recurse on the rest of the string. And we'll keep doing that for the length of the string. So let's get started. We've got a recursive solution here. So we are going to do our base cases first. And a base case is, well, let's see. If the length of S is less than 1, actually, let's see what our constraints are. Okay, so it has to be at least 1, which is good. So if the length of S is equal to 1, then we can return 1. Because a one character string is a palindrome, because it reads the same forward and backward. I guess I didn't mention what a palindrome is. A palindrome is just a string that can read the same forward and backwards. So it's just a string that is a mirror image of itself. Okay, so if we have a single character string, it is a palindrome of length 1. Otherwise, let's see. If is palindrome S, then we'll return the length of S. Okay, so we don't have this is palindrome. We're going to have to write that. But that should be pretty straightforward. So let's write that here. So is palindrome, and we'll take P, and it will return P is equal to the reverse of P. And we can reverse a P. That sounded funny. And we can reverse a string or any iterable just by going through taking slices with a -1 step. So colon, colon, -1, that will reverse this string. So a palindrome will be when the string is equal to its mirror image or the reverse of that string. Okay, so we have if the length is 1, we'll return 1. If it's a palindrome, we'll return the length of the string itself. If it's not a palindrome, now we have to go through and remove each character, but just one character at a time. So let's see, for index in the length of our string. So we will remove just the first character and recurse on the rest. Then we'll remove the second character and recurse on the rest. So we'll need to keep some current result. So our current result will equal to 0. And at the end, we will return our result. But in between, so how do we remove one character at a time? We could go through and delete the character, but then we'll have to remember to put it back in the right place. I think what I'll do is I'll keep a left side of the string and a right side of the string. And then we'll put them together to make a new string. That's going to be left plus right, so we concatenate them. And then this option will be, let's see, we'll have to call self, and we'll recurse on this new string. And then our result will equal the max of our current result, or this option. All right, now the thing I haven't done yet is actually breaking out the left and right, because that's where it gets a little bit tricky. So we're going to have to slice our left out of our string and the right out of our string. Well, let's see, our left will go from 0 up to, let's see, it'll be our string from 0 up to this index I. So if we start at 0, it'll be 0 to 0, but this is non-inclusive. So this will be an empty string to start with, which means that on the right side, we want to go from I to the end, but it's actually going to be I plus 1 to the end. So again, if we start at 0, this S will go up to 0, meaning this will be an empty string. So index 0 is not included. And we don't want to include index 0 on the right because we're eliminating the character at index 0. So we can't say S of 0 to the end. We have to say S of I plus 1 to the end. Okay, so now we have our left and our right. We create a new string, and then we recurse. So this is our basic algorithm here. We have some base cases. We're checking to see if we have a palindrome. If we do, then we can return the length of this string. Otherwise, we go through, we pluck out one character at a time. So in the first pass, we'll remove character at index 0. On the second pass, we remove just the character at index 2. So this will still have the character at index 0. Then third pass, we'll remove character index 3, and so on and so forth, and we recurse. And we just choose whichever one gives us the maximum result. Now you might be thinking, well, what about removing 2 characters or 3 characters? And that's totally legit. But that's going to happen in our recursive call. In this call, we've removed 1 character. Then inside of that recursive call, it's going to go through and remove 1 character at a time again. So that's going to be the second character. And every recursive call from there is going to remove another character, which is removing 3 total characters. So this should do it. Let's give this a shot. All right, let's see. That's right, I need to do range of length S. There we go. And this is misspelled. Oh man, so many typos. Let's see if this looks better. All right, third time's the charm, and it works. So this algorithm does work. Now we'll run it, but I have a feeling it won't actually pass all the tests. So this algorithm works, but it's going to be slow. Recursive calls in general are slow, but there's something in here that we're doing that's making it even slower. And I'll come back to that if we don't pass. All right, so our time limit is exceeded, and oh man, we don't do very well. We only passed 10 out of 86 of our test cases. So let's use this as our test case, and let's try this again. It's going to say time limit exceeded. We already know this. So how do we make this faster? Well, one thing we can do to make this faster is to actually not have to do this over and over and over again for the same inputs. So you might notice if we go through for this example, B, 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 B. So we have this. So we'll go through, we'll remove the first B, and then we'll recurse on these 3 Bs. Then in our second loop through, we'll remove the second B, but we still have the same input then. It'll be B, B, B. Then the third time, we'll remove the third B, but it'll still be B, B, B. So we're doing the same call multiple times. We're calling this function on the same input, B, 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 at least 3 or 4 times. So one thing that we can do to speed this up is use cache. So Python gives us this function. So from functools, we import cache. Now cache is a function decorator. You put an at cache before your function, and it will basically cache the result for a given input. So given the same input, it will cache the result. It will do the calculation the first time, but anytime it gets the same input again, it will just check the cache and return the value. So it won't have to do the entire function again. So this should save us some time. Let's see if this passes. And now we do pass our third test case. So that actually does save us time. Let's submit this and see how we do. Taking a long time. And again, our time limit is exceeded. But this time we passed 61 out of our test cases. So we do significantly better with the cache than we did without the cache. But we still aren't good enough to pass all the tests. Now, we're getting 61 out of 86, which is pretty good. We would need to boost this another 20% or so to get it up to 80, maybe 30%. There's not a whole lot I can do to boost this in this particular algorithm. We could maybe speed this up because this isn't going to be the fastest way to check for a palindrome. We could speed this up a little bit and that might give us some gains. But instead, I think I have an idea for a better algorithm. So kind of going through this, I was thinking about this. So every time we go through our loop, we either have a palindrome or we remove one character and try to get a palindrome from the rest of the sequence. Now we could do the same thing. Instead of doing a recursive call, we could just have two pointers. So this is very similar to, if you've ever done a problem that's like you get two input strings and you try to find the longest common subsequence between the two input strings. So in that algorithm, you essentially keep a pointer to the first or last characters in each of the strings. And either those two characters are the same and you advance both pointers, or the characters are different and you take turns, you either advance the left pointer or the right pointer or the top pointer or the bottom pointer, whichever way you think about it. But I think we can do the same thing here. So we're going to throw this out and try an entirely new algorithm. We don't need this caching because I don't think this will be recursing. Okay, so now, new algorithm. We will keep a pointer to characters, a left pointer and a right pointer, or start and end, whichever one you like. So we'll have one at the very beginning of our string and one at the very end of the string. Now, if those two characters are the same, then we can include them in our palindrome. So we can add, let's see, that would be 2 characters to our result. So we have both the left and right characters, they're the same. That means our palindrome is at least 2 characters long. Then we move both of the pointers together. So we move the left one to the right and we move the right one to the left. So we move them closer together. Then we check those characters. If they're the same, we can add another 2 to our palindrome, and we keep going until our left and right cross. Now, what happens if they're not the same? Now, if our characters at those 2 pointers are not the same, well, then we have 2 options. We can throw away the right character, or we can throw away the left character. So we'll just try both. In one, we'll advance the right pointer, and the other will advance the left pointer. And then we'll check to see if that results in any palindromes. Okay, so hopefully that makes sense. If not, maybe this code will help. So we will define a new function here that instead of taking just the string, it will take the left and right pointers. So let's see. I'll call this palindrome length. All right, and we'll take a left and a right. So the left will be an index of the leftmost character in our window, and the right will be the index of the rightmost character in our window. All right, so what are our options? This will still be a recursive call, so we're going to want to check, let me spell this right first. So the first thing we'll check is, are the left and right indices defining a window? So how do we still have some characters, basically what it comes down to. Okay, so our first base case is, if the left is greater than our right, then we no longer have any characters from the left to the right, so we'll return 0. Now what about if the left is equal to the right? That's the next base case. If the left is equal to the right, then this is a 1-character palindrome, and we know we can return 1. All right, now we know we have a left that's to the left of the right, and we have a right that's to the right of the left. So we have 2 unique characters to check. Okay, so if our S at our left is equal to the character at the right, so now we have a character on either side of our window that match, which means that they are part of our palindrome. So we can say, let's keep our result here. We'll start our result at 0. And at this point, we have 2 matching characters. So our result can increment by 2. So we increase the result by 2. And then we need to recurse. So then we can say the result is equal to palindrome length actually plus equals our palindrome length of our left plus 1 and our right minus 1. So we advance the left and we move the right, so they're moving closer together because those 2 characters matched. Now we move on to the next set of characters to check. And then we return our result here. All right, now if they don't match, that's when we have 2 options here. So we have option 1. So now option 1, we will basically call this recursive call, but we'll move just the left. So left plus 1, right. So now we'll ignore the left character. Because our left and right characters don't match, we need to ignore one of them. So we'll ignore the left character, we'll move on, we'll basically remove that left character, we'll move on, and now we have a new window, left plus 1 to right. And those characters might match, so we do the recurse and we have option 1. Now, option 2 is basically the same thing, except for this time we'll ignore the right character. So we're going to keep our left as the same, but we'll take our right down by 1. So we're throwing out that right character and we're moving on. And then at the end, we can just return the maximum of option 1 or option 2. So if option 1 gives us the maximum result, then that's our best bet. Otherwise, we'll go with option 2. Okay, so that should cover it. Now, finally down here, we need to make our initial call. So we need to call this function for the first time, and we call it with left is 0. That's our leftmost character. And then our rightmost character will be the length of s minus 1. All right, so this should do it. Now, one thing you might notice in here, we're saying result is 0. We're adding 2 to the result, and then we're adding this recursive call to the result, and then we're returning that result. We don't actually need this result. We could just say, let's see, this starts at 0, then it becomes 2 here. So we can actually just get rid of this here. And then this is just result plus this. So this is really just 2 plus this. So you can get rid of this. Now we just have result is equal to 2 plus the recursive call. And then we're just returning the result. So in fact, we could just say, well, why don't we just return 2 plus the recursive call? All right, so that saves us one variable. All right, this looks pretty clean. Let's check it out. So we have a left and right that define our window. If the left is greater than the right, that means we've closed our window, so we'll return 0. If the left is equal to the right, that means we have one character and we can return 1. Otherwise, let's check the characters at those indices. So if the character at the left is equal to the character at the right, then we have 2 new characters in our palindrome, the left and the right character. And then we can call recurse on our palindrome length, passing in the left plus 1 and the right minus 1. So we move to the next characters to check. If these characters don't match, well, then we have 2 options. We can either throw away the left character, so that's option 1, or we can throw away the right character, and that's option 2. And finally, we'll just return whichever one gives us the better result. Okay, let's see if this works. It's taking a long time. So we still have a time limit exceeded, but as you notice here, we're not caching our result the way we did in our previous example. So will caching help in this case? Well, let's think about this. So in one option, like this BBBB, we're going to be advancing and just moving to this set BBB. And the other option will be advancing to this set. Well, in that case, it will help because we are going to be calling this palindrome length on the same set of characters multiple times. So let's add our caching back. So this is from func tools, import cache. And we'll add our decorator before our internal function. Let's see if this helps. That makes a huge difference. Wow, that was blazing fast. All right, let's submit this and see how it does. And we do all right. We pass and we beat 87% for runtime and 6% for memory. That is not too bad. Let's see, we've got 6 minutes, so I will see if I can get this over 90%. No guarantees. Okay, so what can we do to speed this up a little bit? Well, one thing, we're calling this max. So sometimes calling a max function will be slow. So we can say return option 1 if option 1 is greater than option 2. Else we'll return option 2. So this is basically the same as the max function. If option 1, we'll return option 1 if option 1 is greater than option 2. Otherwise we return option 2. Same thing as the max function, but we're not making a function call, so this should be faster. Or else can we speed this up? I could get rid of some of these white spaces. I don't think that makes a huge difference. I like it this way anyway. So let's do this. And that gives us a huge bump. That's what we needed. So now we're at 97% for runtime and 11% for memory. So changing that max function, removing the function call and just replacing it with our own conditional makes a huge difference. All right, well, I'm gonna leave it there. I call that a win. 97% for runtime, 11% for memory. See if you can do better. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.